Good afternoon, Asia. Good morning to Europe. Today, thank you very much for joining us with our webinar with the title of Visualization and Simulation Model of Railway Station Fire Disaster, Fire and Smoke Simulation, Evacuation Simulation, and VR by using our PTV Viswalk software. So first of all, let me introduce myself. I'm Sarat Chai from Thailand, Team Consulting, Engineering and Management. I graduated from Traffic Engineering School. So I've been working in traffic engineering for 14 years. And at the same time, 7 years ago, I have started working in BIM, Building Information Modeling. So that's why today I pick up this topic of the integration between BIM and micro simulation. How could they work together? Next, let me discuss a bit about. Let I introduce a bit about my company. Team Group is a kind of integrated engineering consultant company in the fields of transportation, water, hydropower, reservoir, EIA, building infrastructure, energy, with more than 1,000 staff. Okay, this is the outline of today's webinar. It is about utilizing BIM, Building Information Modeling, of a railway line which contains 30 railway stations for disaster simulation. And so I suppose that most of audience today would be in traffic engineering. So I would talk a bit about what is BIM. And next topic is using BIM and simulation. And next is about the evacuation simulation. And next is fire and smoke simulation, or FDS, fire dynamic simulator. And virtual reality, or VR. And our major topic today is our showcase of some railway stations. Okay, first of all, let me introduce a bit what is BIM. BIM stands for Building Information Modeling. If I have limited time to explain, I would say that BIM is something like 3D model plus information technology inside. So those information would include the material properties, how long it can stand for, it can resist for the fire or energy explosion inside, and the quantity and construction method, the maintenance, and so on. Okay, let's see some development of the BIM. I would say that there are 4 major generations. First one is a hand drafting. Yes, 30, 40 years ago, everything in this world created from hand drawing. But the recent 20 years ago, a platform called CAD, or something like AutoCAD, 2D drawings has been very popular until now. And some recent years, you might heard about making 3D model like SketchUp. You can create 3D building, but it's not really accurate in engineering term. So the 4th generation is a BIM generation, which contains a 3D model plus very accurate engineering information inside. And other than 3D, what else that BIM could do? Okay, 3D, we would talk about visualization or some crash analysis, some constructability analysis. And for 4D is something like you add time element to the 3D model, so you can visualize construction sequencing, construction scheduling, construction method. And when you add the cost element, BIM would become 5D. The cost element would include the quantity of work and cash flow management, or even the manpower management. Today, our major topic is 6D model. Usually include wind load analysis, seismic load analysis, airflow analysis of, it could be like someone sneezed in a hospital. How wide would it spread? Okay, let's see some further example of 3D. Okay, this one is an example of a parking building. So for parking building, for the general contractors, they would interested in in the constructability, whether there's some crash between the plumbings and the structure or the architect works. But for us, for traffic engineers, what would you check? We would check about the vertical clearance, like what is the maximum height that the van could get inside. For some place it would be 2.2 or 2.4 meters. Furthermore, you would check about the turning radius. So these are the benefit of 3D BIM for traffic engineers. Next, let's talk about I give you some example of 4D and 5D BIM. Okay, let's see. Okay, this is 4D. When you add the time, you can see this is Gantt chart of construction schedule. When you link between 3D and time, you get 4D. As the times go by, you can see the construction progress. And also, if you add the cash flow to here, you could see at which progress, at like 70% of the construction, how much the cash flow in and out. So you can use this information for construction management. Okay, next is our major topic today. It's about 6D engineering analysis. So usually you might have heard about structural analysis, EIA, environmental impact analysis, or energy consumption analysis, or even the traffic simulation. Like, for example, for this station, there would be a drop off here, or a bus station here. Usually you can do how long does it take for each queue, something like that. But today, I like to talk about just evacuation during the disaster. Okay, let's give some talk about the pedestrian simulation, not for normal operation, not for the evacuation. Okay, this one is an example of an airport. During the design process, designer says that suppose 2 booths of immigration would be enough, but we have recheck and confirm that no, it's not is enough for the normal operation. But sometimes during the peak hour, like for example, if there are two shuttle flights arrive at the same time, uh, only two booth would not be enough. So we add another 3. So totally, finally, we have 5 immigration booths in order to maintain the level of service. Next is about the fire dynamics simulator. Okay, let's give you some example of a subway station. Okay, this subway station also designed in BIM, and we export the BIM model to FDS, the fire simulator, to check how well the exhaust fans would work effectively or not. So according to this result, it shows that the exhaust fans could control the spreading of the smoke and the heat and the toxic, not to spreading to the whole station. So it would allow the passengers have time to evacuate without much panic. And next topic, I would like to talk about virtual reality. So the previous simulation of evacuation and the fire simulation, the point of view is from somewhere else. But for VR, virtual reality, we can really see what the passenger will see during the evacuation. So we can decide whether our signage board or our evacuation route is easy for understanding or not. For example, this one shows the previous subway that if a passenger leave from the train, he or she would see this route, and he or she will see this staircase and follow the fire exit signage and evacuate to the top. Okay, and thanks to the recent technology that you can use smartphone for this kind of VR, and you can buy cardboard, VR cardboard maybe from the internet. It just costs like $3 or $5. Okay, now I like to talk about our major topic today. Is our showcase of a train, a railway lines. A railway line include 30 stations, but most of them are the typical type. So, okay. According to our government agency, we don't really have our own standard. So government agency just asked to use to follow the NFPA standard. So NFPA stands for National Fire Protection Association. It is an international non-profit organization dedicated to eliminating death, injury, or any loss due to fire. So for this project, we follow NFPA 130, which is for standard for fixed guideway transit and passenger rail. And inside this code, it requires us to use simulate the number of the number of passengers would include 2 fully loaded trains because there are 2 tracks inside the station, plus forecast passenger number on the platforms. So totally, some stations would contain up to 2,000 passengers during the incident. And all passengers must leave the platform within 4 minutes. And all must reach the fare gate within 6 minutes. So if you see the requirement, you might think that, okay, why don't we just run Viswalk simulation and assign passengers to run as fast as we want? No, you cannot really do that because NFPA mentioned that these are the maximum speed for evacuation in order to make everyone safe. And yeah, because if someone runs, he or she would create some other accident, especially at the staircases. So these are the maximum speed during the evacuation. Okay, the maximum speed at the platform is 38 meters per minute. At the concourse is 32 meters per minute. And at the staircases is 15 meters per minute, or if converted to the floor, for 1.5 meter width staircase, the maximum flow would be 84 persons per minute, and for the 3.3 meter width staircase, maximum flow would be 180 persons per minute. And the maximum flow at the fare gate is 50 persons per minute. Okay, next is about exposure time to the heat. At the heat of 80 Celsius degree, passenger can stand not longer than 4 minutes. And about the visibility because of the smoke, it requires 80 lux at 30 meters. Next is about the toxic gases for carbon monoxide. Up to 2000 ppm, passengers can stand for a few seconds, and up to 1000 ppm, passengers can stand for 6 minutes. Okay, those are the requirements from NFPA 130 code. Next, let's see our overall station. You can see that this is designed in BIM, including structural works, architectural works, and mechanical, electrical, plumbing works. So, but in order to do the simulation in Viswalk or evacuation, we don't really use all the information. Okay, let me show you. For example, okay, this is our real case. We export the station that you see in earlier slide, but we hide some layers like the roofs because it's not very necessary and it's not really related to evacuation, but we still maintain necessary information like the number of the trains, the location of the door at the train, the sizing of the staircases, everything are exact the same in the design. So we can see every single behavior related to the dimension of the station. Like you can see every turn of the station at the staircases, something like that. And plus, in real life, well, PTV Viswalk react very realistic behavior. Like, for example, you can see this staircase is U-shape, and this one is a straight shape. So if you use spreadsheet to do calculation, you will get the same result, because in spreadsheet you don't care what kind of the shape, what is the shape of the staircase it is. But when it comes to the PTV Viswalk simulation, this one is very realistic. You can see that at the turning point, people walk slower, which is similar to the real situation. So you can really see every single details of evacuation. And here you might see these two extra staircases. Yes, they were added later, because at the first analysis, people could not leave from the platform within 4 minutes. So that's why the designer added 2 extra, so passenger could leave within 4 minutes. And yes, that's why this one is a successful case. Passenger could leave from the platform within 4 minutes and leave to reach the target within 6 minutes. Okay, next I like to talk about the FDS. Okay, why we have to do the flight simulation? Because we have to make sure that during the evacuation, during those 4 or 6 minutes, the environment inside the station would be safe for evacuation and will not make our passengers be too panic. Okay, so some of the worst cases are this one. This room is called AARU room. It is the room that store the brake energy of the trains and store inside. And for some bad days, it would explode. And when it explodes, the heat and the smoke would leak from the room. And yeah, so this simulation shows what it looks like. Where is the heat and where is the smoke could go. So usually the hot air just go to the top of the station. But however, this one could not really say that this simulator could not really say that our passengers are safe, because you simulate without any passengers, without any evacuation activities. So thanks to our latest technology of PTV Viswalk 20, version 20, we can combine the evacuation simulation you can see in this animation and the FDS combined together and run at the same time. So you can really see what would happen when it starts burning, whether the hot air, the smoke would affect to the evacuation path, would be harmful to our passengers. So okay, let me show you some other angles. You can see that okay, when it starts burning, the hot air and the smoke spreading to the top. I mean, from this is the concourse level. The hot air is going up to the platform level, but it could not really go to the platform. It could go underneath the tracks and under the trains, because for this station we designed for the PSD, pedestrian sliding door, so people on the platform are not affected by the hot air and the smoke. Okay, so I think this one would be very useful tool for simulation, because it could use very accurate data of engineering from the design, because it's designed in BIM, and at the same time it could combine FDS fire dynamic simulation result together with the pedestrian simulation. So it would be very good tools for the safety. And the final topic of today, I'd like to talk about VR for this station. That, for example, if someone leaves from the train, what he would really see, okay, he would see a signage somewhere for the exit, and he goes to the the additional staircase and evacuate to the safety point. And for this video could show that, okay, the evacuation part is not that difficult to understand. Even he or she might never been at this station, because I think it's quite easy to understand, because you can see the many guide signage. Okay, and I think that's all for today's webinar. And we are welcome for any questions if you have, or any comments or whatever.
Okay, hi, Dr. Sarachai. Hi, everyone. This is Summer from PTV Group. So we have a few questions from the ground. The first question is, can PWDs also be included in the simulations? How are they considered in the evacuation simulation?
I'm sorry, PWD?
Yeah,
what?
I think he meant people with disabilities.
Yes, for this one, actually we have talked to the government agency about this. For our own simulation, we can technically do it, but for the real fire strategy, the government have its own fire strategy to use manually to assign a staff to help disabled people during the evacuation. So that's why in this study we did not include any disabled people, any handicapped people. Yes. Hello.
Hello.
Hello,
Okay.
Summer. Okay.
Thank you for your answer. The next question that we have is, do you normally do lift evacuation and people in wheelchair evacuations?
Sorry, I did not catch the last. Could you please repeat again?
Do you normally do lift evacuation?
You mean elevator?
Yes.
According to our regulations and laws, during the evacuation, you cannot use elevators.
Mm.
So we didn't do that because when it comes to the fire incident, you're not allowed to use. And actually, the elevators are automatically locked during the incident.
Thank you. And the next question we have is, does station assistant people to be modeled to help people with restricted mobility to evacuate? I believe this is addressed regarding the people with
Yes,
disabilities
yes.
questions. Yeah. Next one is VR generated in Viswalk or BIM?
We are generated in other BIM software, not Viswalk.
Okay. And we have another question. How can we differentiate by the severity of the fire? The evacuation procedure for different severity levels should be different, right? And shouldn't the area affected by the fire be considered?
Yes, this is very good question. I have to say that because today we have limited time, so that's why I just show only one case of the fire simulation. But for our real project, each station we run fire simulation 3 times for no more than three cases, from some small fire or to the biggest one, and each one uh, each one have each one has a bit different output and a bit different fire strategy. So yes, you're right. At a different kind of fire incident, there would be some different details. For example, if some for some cases the source is very close to the staircase, so some staircase would be closed during the fire evacuation. So we have to test those kind of stations too. Yes.
Okay, thank you, Dr. Sartrai. We have two more questions.
Yes.
Okay, so this question, it is interesting to know that we can incorporate fire and smoke simulation in VISIM. May I understand if the pedestrian escape route could change dynamically as the fire and smoke grow closer to the escape route over time?
Mm, I would say yes, but it manually. It's not that automatic at the moment. We have okay. The process is we have to run the fire for the first time and see the effect. Where is the fire is going? And later we use that result from the fire simulation to design our evacuation simulation. Like, okay, for example, we already know that the staircase number 1 will be closed because of the fire, something like that. Or this room, um, the evacuation route would change later, something like that. So we can do it. I would say we can do it manually with a number of you have to do 5 simulations first. Yeah.
Okay, and we have another question. Can you incorporate mechanical system also on this? For example, mechanical system for pressurization of fire exit stairs.
Yes, yes. As I mentioned earlier in the subway station, if you remember, I mentioned about the exhaust fans. Yeah, those exhaust fans are kind of mechanical tools. Yes, we can do it.
Okay, and we also have another question coming in. Can a scenario be modeled where there is a crowd at the emergency exit gates or routes? Looking at that, several people or group of people behaves randomly and choose a wrong path.
I'm sorry, I don't understand. Could you repeat again?
Okay. The question is, can the scenario be modeled where there is a crowd at the
Yes.
emergency exit? So for example, there may be several people or a group of people who actually behaves or walks randomly and then they choose another route.
That's possible. That's possible. Like if you see, okay, let me show you the video. Okay, let's say that someone in between. I mean, usually people just choose the staircase which is the closest one. But if someone standing between, they can choose whether the left or the right. In our software PTV Viswalk, you can do both randomly, or you can assign that passenger could prefer to use any specific route. You can do both. Yeah.
Okay. We don't have any more questions from the ground.
If there's no other further questions, I'd like to address about VR. That I think one audience asked about it. Like, yeah, at the moment we cannot generate VR inside our Viswalk, but I think in the future, if we can incorporate VR in our Viswalk, it would be very interesting that we can really generate what the passengers could really see during the evacuation. This is my comment to the headquarters. May I? Hello, Summer.
We'll take this into to our headquarters. We actually have one
Okay.
more question coming in, just come in.
Okay.
The question is, are there any videos available regarding the development of model for emergency scenario?
Pardon me. What is the question again, please?
The question is, are there any videos available regarding the development of model for emergency scenario?
I don't understand the question. Could you please help me?
I think we will get back to you regarding this from the PTV side on the development of the model for the emergency scenario. Yeah, to the
Like some training?
she's asking about the videos for the development of model for emergency scenarios. Yeah.
So she asked for some training, right? PTV Viswalk training.
Videos.
I don't really understand what is the meaning of video, but I think she might ask about some instructions for making the model by their own, something like that, right?
We will clarify with her on this again. Yeah.
Okay, okay, okay.
Okay. So now we don't any just to confirm that if anyone has any more questions, please put it in the question box, or if not, please send an email to us. So I don't have any questions from the ground right now. Dr. Sarachai, back to you.
Okay, okay. So thank you very much for having me today. I'm very appreciate with you all, even I don't see your face. Okay, let's hope that we can see each other in the real life later when the situation allows us to do that. So okay, thank you very much, and I'm happy if anyone wants to send me another questions or comment, we're happy to have that. Okay, thank you very much.